Hey team, Andre from High Performance Academy here. Welcome to another one of our webinars, and this week we're going to be covering off some of the basics of fault finding and diagnostics, specifically when it comes to wiring. This is probably one of the most important skills that any budding tuner or mechanic for that matter should understand. However, I know that a lot of people, particularly those just getting started, tend to be put off a little bit because it does involve wiring. So we'll show you some of the more common faults that I've come across in my career and show you how you can fault find and diagnose those without needing any expensive equipment. Before we get into that though, just a little bit of an update on what's been going on over the last couple of weeks since our last webinar, and we'll start just by reminding you that we do have one of our giveaways running at the moment. There are only 6 days left to go here. We are giving away a Racetech RT 4100 HR race seat. So the HR stands for head restraints. So this is a nice modern designed race seat. It gives you the head restraints that come around the side of your helmet, which goes a long way to supporting your head and neck in the event of a sideways impact. So much safer than the older style seat without that head restraint. On top of this, we are also including a 6-point lightweight harness and our driver training courses as well, so that you're going to know what to do with your race seat once you get it out on the racetrack in your car. So for anyone who's contemplating a freshen up of their existing race car, or maybe you are embarking on a new race car project build, this is the perfect giveaway for you. It's valued at over $2,000 US, and as I mentioned, there are only 6 days left to get your name into the draw. There's a link that Scott will drop into the comments that you can follow to get your name into the draw. There is no cost, no risk with getting your name into the draw, so please do so. There are a few other tasks you can complete as well that will give you a few additional entries. Alrighty, I wanted to start by just giving you a bit of an update on our FJ40 project. This one has been dragging on a little bit longer than I'd like. Pretty typical with most projects though, let's be honest. And if you haven't been following us for a while, maybe you're completely unaware. So let's jump over to my laptop screen. This is the car in question. So it's a classic 1982 Toyota FJ40. This is actually my daily driver. Possibly not quite what you expected, but I've always loved the look of the old Toyota Land Cruisers. However, I wanted to modernize it a little bit. I'm not going to go too deep into that, but just as a quick recap, it's basically got a conversion in terms of engine and gearbox, running a 4.3 litre Toyota V8, modern 5-speed gearbox, power steering, disc brakes all round, and coilover suspension, just to name a few of the aspects we're dealing with. Now, as part of this, as you could probably understand, there's a fair bit of wiring that needs to be changed. In fact, every single wire is getting ripped out of the car, and we are completely starting from scratch. This is going to be documented in a couple of our courses. We will be documenting the build of the engine harness in our professional motorsport wiring harness construction course. So if you're interested in learning how to work with the likes of Autosport connectors, I think I've got one lying around here. Yeah, here we go. Autosport connectors like this little guy, we're going to be dealing with something a little bit bigger than that. And you're interested in learning how to build concentrically twisted harnesses and work with all of the other aspects that are synonymous with motorsport wiring harness or professional level motorsport wiring harness construction, like DMC, Daniels Manufacturing Corp crimp tools, the positioners that go along with those, as well as heat molded boots and transitions, etc. This course is perfect. The course is already there. It includes a nice, easy to follow 10-step process that you can use irrespective of what you're personally building a harness for. Could be a simple chassis harness, or you could be doing a full-blown, complete start to finish, front to back harness construction like we're doing with this car. It will teach you all of the skills that you need to understand as you go along with this, including the often talked about but very, very infrequently demonstrated technique of concentrically twisting. And this is something we've been been constantly questioned about since we very first started with our wiring courses. Now, one of the problems with doing a harness like this, and I think this is one of the areas that a lot of people get put off, is in those initial planning stages. And I just wanted to cover some of the real basics of this here in today's pre-show. And what I'm talking about here is understanding what you actually need to incorporate into your harness. This is really critical, because if you miss something here, you overlook something, or maybe you don't understand how something needs to be wired, it can make it very difficult to come back from that and recover it at a later point, particularly if you're dealing with a mil-spec style harness which is sheathed with DR25. Once that's constructed, it's sheathed and everything's shrunk down, it's very hard to add additional wires. So what I'm going to do is, if I can just find my little place here, I'm going to cover off how I've gone about this. So let's head over to my laptop screen for a moment. And the first place to start is with the ECU, and it doesn't matter what that ECU happens to be. We're using the Motec M170 here, but every manufacturer will have data sheets for the ECU, and this is from Motec here. In particular here, some of the key aspects, including the auxiliary outputs and the inputs that we will be dealing with, also the injector and ignition. Now, why that's really critical is we want to make sure, obviously, right from the very get-go, that we've got an ECU that physically has enough inputs and outputs to do everything we want to do. And this actually got to be pretty close on our 4.3 litre Toyota V8. This is the first process in actually deciding on which ECU will suit our application. And again, getting this wrong can be really expensive. It's not just a case of adding wires. If you realize you've forgotten something, if you don't have an auxiliary output spare to drive your boost control solenoid or whatever it may be, well, that's going to be pretty tough to come back from. So once we've decided on the ECU, then it's a case of figuring out how all of that's going to work. So this is as simple as this needs to be. This is kind of my initial planning sheet here. So what we've got here is the wiring harness, obviously for the engine, and we've got listed out here everything that will be included here. So right through to, we can see here our drive-by-wire throttle, for example. But it's not just the drive-by-wire throttle. We need to break that down further into what does a drive-by-wire throttle need. So it's got two half bridges, which we can see there. So that physically drives the servo motor for the drive-by-wire throttle. But it's also going to have two position sensor inputs back to the ECU to essentially tell the ECU what the throttle plate angle or position is. That requires a sensor 5 volt, regulated 5 volt supply, and a sensor 0 volt. On top of that, we've got two analog voltage inputs, which are our TPS1 and TPS2, or TPS and TPS main and TPS tracking, I think, if we want to be really specific about Motec lingo. The other aspect that's important to understand here is what we need in terms of the engine speed and position, and that's a little bit more complex with a variable valve timing engine like our 3UZFE. So we've got, again, in Motec lingo, reference, which is the engine speed sensor coming straight from the crankshaft. We're using a universal digital input there and a 0 volt. It is a reluctor sensor. So again, we need to understand how that sensor works. In the case of a reluctor sensor, we're dealing with a 2-wire sensor. It runs a 0 volt and the actual input to the ECU. A Hall or optical sensor would need a voltage supply as well. On top of that, we also need a synchronization sensor that runs off the front of the bank 1 camshaft, and this gives the ECU information on whereabouts it is in the engine cycle. The other part, though, that's really key for the variable valve timing to work is we have two cam position sensors. So those are all on universal digital inputs. And we've got some of the sensors that we want to add in here: oil pressure, fuel pressure. We've got manifold pressure, engine coolant temperature, air temperature, oil temperature, and because we can, we're chucking a flex fuel sensor on it as well. Some of the other aspects we need to consider here is our power steering and our aircon control. These are really easy to overlook, so we want to make sure that we have dialed all of that in and we've got everything that we need going on. Now, I've also got a couple of aspects here that are going to be incorporated into this harness just to get the wiring through the bulkhead or firewall connector, which will be an Autosport connector, and then they're going to branch off, in this case, to a dash. So for example, actually a dash and a PDM. For example, we've got our starter solenoid, our oil level switch, as well as a four-wheel drive switch. So those will be going to a power distribution module as well as our C127 dash. Now, once we've got all of that listed out, we can sort of come back up here and you can see what I've done is I've totaled everything up that I am using, gone through and I've double checked, hence you can see the little green tick marks there, just to make sure that I have got an accurate total. We can then compare that back to our Motec data sheet and make sure that we've got the right number of outputs. From here, if we scroll down, we'll actually find the pinouts for that Motec M170. That uses a single 66 position Autosport connector, and we can see everything that is included. Now, why this is important is that when we go to the next step, and I haven't quite completed this yet, but I'll show you what we're dealing with. If we look at something like our battery ground, our battery main power ground for the ECU. Okay, well that's easy, we need that. But in this case, if we look here, we can see we've actually got 2 battery negatives there, and we've got another 3 here. So there's actually 5 dedicated contacts in that Autosport connector that will be battery grounds. So we need to understand that we need more than 1. And this is just about current sharing as much as anything. While there's not going to be huge current running through the ground system there will be some, and it just spreads that load out. So likewise, we can see everything that is included there in the Autosport connector and make sure that our pinouts are correct. And if we head back over to our planner at the moment, not that, again, this isn't complete, but if we come over to our firewall connector here, what I've done is just laid everything out. In this case, I'm using a 79 position 22 gauge 22 size contacts Autosport connector for the firewall. So we've got, for example, our injectors 1 through to 8, and then we've got the 2 12-volt feeds that we're going to have going through to those. But where it gets really important is if we come down to our reference and our sync inputs here, we can see that we also need to include a shield pass through. So these are the little aspects that we need to make sure we haven't forgotten about. We need a position on that Autosport connector to pass the shielding through so we can re-establish that on the other side. Likewise, if we scroll back up for our ignition system, well, it's probably a little bit of overkill. I've got a single 22 gauge 12-volt feed running to each of the coils. So we scroll down and we can see that with the setup as we've got it at the moment, we've actually got 2 spare positions on that particular connector. Once I go a little bit further, we can then start sort of establishing exactly where on that connector each is going to be and where it will align to the representative pin, either on the Autosport connector or the internal connector. So it doesn't have to be too tricky. It's a case of not becoming overwhelmed with the amount of work that needs to be done, and it's a case of just starting at the start and working methodically through that. And again, of course, our professional motorsport and our practical club level wiring courses will cover off this in a lot more detail, but I just want to break this down and show you that it's actually not as scary as a lot of people think that it is. One other aspect when we are dealing with this as well, we do need to just be a little bit mindful of understanding what current will be being consumed on each of the circuits, and making sure that we are sizing our wire appropriately, and particularly when we are dealing with an Autosport connector both at the ECU and the firewall that has 22 gauge contacts. Obviously that's our limit on our wiring size. They'll handle around about 6 amps, which in most instances should be plenty. However, in some instances we may also need to double up there, and particularly when we're dealing with our 12-volt feeds through the firewall, we may need to split. So if we're going to be drawing more than 6 amps on a particular circuit, we need to then provide 2 contacts. So that's the sort of consideration we need to go through before we make sure that we are comfortable that we're not going to run out of positions on our Autosport connector. Now, I also want to just quickly cover off some of the aspects of the power distribution module that we are using here. I'm not going to go into too much detail because there are about 3/4 of the way through filming and editing a specific video that's going to go up on our YouTube probably in the not too distant future. And I don't want to spoil the fun because there was some quite interesting stuff that went into that. But when we are dealing with a power distribution module like this one from Motec, this is their PDM32, it is worth in some instances just going to the trouble of doing some bench testing just to make sure that some of the functions that maybe are a little bit more complex, we can work through, test, make sure that the output works as we envisage before we commit to our wiring. And there's two elements with that I wanted to just cover off for you. The first is on our FJ40, we are running, I'll just get it into shot here, a Audi electric handbrake. So this is on the rear of the car, probably goes without saying. In stock form, the FJ40 is a drum brake all-round type vehicle, and converting to a disc brake does add some complexities around the handbrake. So what we did is we decided to go to an Audi electric handbrake or electric brake caliper, so both hydraulically and electrically actuated, and that seemed on face value to be a pretty simple solution, and it is a nice clean solution. However, the actual driving of that caused a few headaches, in particular because the output here, which we've got wired up to a DT connector, this basically needs to be polarity reversed. Basically to drive the handbrake on, 12 volts to one wire, ground to the other, then to drive the handbrake off or release it, we reverse that. We can't do that using the Motec PDM. They do not include half bridge outputs, and yes, some PDMs do that, so that would make things a little bit more simple for us, but in this case that's not how it works. So we got around this in a reasonably interesting way. We ended up using a Motec dual half bridge controller. So this, as its name implies, includes two half bridge outputs. So what we can do with that is either drive two servo motors in a single direction, so you could use this to control maybe a pair of thermofans or a fan and a fuel pump, and you can speed control, or alternatively you can control a single servo motor in two directions. So one of the complexities around this is that we need to target a specific current in order to make this handbrake basically clamp sufficiently. It basically targets 18 amps. And the PDM does a nice job of helping us there because it monitors, of course, the current. Problem is that we could not control the dual half bridge controller direct from the PDM. There's no way of doing that. So what we employed was the Motec dash that's also going to the system. Again, it's starting to sound a little bit complex, and I admit it is, but most of these electronics other than the DHB were already in the vehicle. So how that works is that the current as well as the handbrake request gets sent on the CAN bus from the PDM to the Motec dash. The Motec dash then controls those dual half bridge, those two half bridge outputs to actually drive the handbrake on and off, and then it monitors the current and disables the handbrake when the correct current has been achieved. And quickly we'll just head over to my laptop screen and show you how that works. So at the top here we've got our PDM input state, so that's our handbrake request. We can see this is where it's turned on. We can then see the next channel down is our handbrake current, so that's the monitored handbrake current being sent to the dash via CAN bus. Won't worry about the other channels because this is really all that counts. So when we turn the handbrake on, immediately we get a really high inrush current. It drops down, and then we can sort of see that the current sits quite low, and then as the handbrake starts to come up on the or clamp the brake pads, we see that current start to rise, and basically when it turns off and it reaches the current limit, we're sitting right on our target there of 18 amps. So pretty happy with how that all works. Obviously drops to 0 there, and then on the other side where we turn the handbrake off, the current, this time it's pretty easy to release the handbrake, goes up to 8 amps and then drops away. So quite a good way of just proving the whole system before we actually commit to the wiring. And again, I'll admit it is probably a pretty complex and expensive way of getting an electronic handbrake. Halfway through, I'll admit I was also thinking, let's just maybe stick to drum brakes on the rear and we'll keep the handbrake cable. But it is ultimately quite a nice solution and only required one additional electronic component, which is that dual half bridge controller. The other thing I'll just quickly talk about is the windscreen wiper motor. This one is a little bit rough and dirty because it's been on the car since 1982. But essentially, I'll just quickly get this under the overhead shot here. Obviously, got the little actuator here. I can't drive it live here, but a lot of people don't really understand the way these work. And basically, we've got a low and a high speed to the motor, which is in here. And inside this mechanism here is the park switch. Because with the park switch, it basically makes sure that the wiper is always going to return to the same place. Now, there are a few complexities with running a wiper motor because quite often, or usually, there will be a dedicated output on the PDM for wiper control. The reason for this is if we've got our low speed functioning and then we switch to the high speed, what that will actually do is generate a voltage on the low speed output into the PDM. And if the PDM isn't designed to deal with that, it can also actually damage the PDM. So you want to be really mindful of following the manufacturer's instructions on how to wire up your wiper motor. A little idiosyncrasy with the Toyota FJ setup there is that it was actually wired to be permanently powered with two grounds that switch instead of basically being permanently grounded and two powers that switch. So we actually needed to do a very small amount of rewiring on that, but again, basically getting that bench tested and then confirming the operation means that when we do commit to the wiring, we know that everything is going to work exactly as intended. Now, on that note as well, I've only really briefly gone over this, but I just want to mention we do have our PDM installation and configuration course out and available. It's $149 US. If my math serves correct, you can use our payment plan and break that down into 8 weekly payments of something like about $18 a week. As with all of our courses, the zero risk getting involved comes with a 60-day, no questions asked money back guarantee. So if you don't think it's quite what you expected, not right for you, no problem, let us know, you'll get a full refund. I'll quickly go over what is included with this. We start with Zach going through some of the technical background and theory of PDMs, what they are and why they're such an advantage over conventional fuses and relays. We'll talk about over and under current, the logic functions which really make up the backbone of how we program the outputs. And a lot of people I know are using power distribution modules, but really just not scratching the surface of what they are capable of doing. These units are so powerful when we get into some of the more complex functionality they offer. Talk about the types of electrical loads, half bridges and full bridges, which obviously I've just talked about today, pulse width modulation, determining current draw. One of the key questions we get is how do we know how much current an output is going to draw? It's actually really, really easy. We also cover some of the practical elements such as working with our large gauge cable, location of it, determining our channel current limits, how to parallel outputs, starter and alternator control, wiper motor control, obviously we just discussed, control pad setup, etc., etc. Some of the more advanced functions here, we've got a case study that Zach covers. So again, this is what I'm talking about with the more complex functions. Really, the sky's the limit. It's up to your imagination, but operating a backup fuel pump if the normal fuel pump is deemed to be faulty, how to set up a pit limiter using a rain light and a headlight flash, how to control an electric water pump using switched and pulse width modulation, how to set up alternator failure output prioritization. Bit of a mouthful. Basically, if your alternator fails and you're out on the racetrack, how we can basically turn off all of the functions that aren't critical to keeping the car out on track, just to hopefully limp the car home. Engine stall recovery, great for race cars that are involved in standing starts to allow the driver to quickly re-engage the starter motor just by depressing the clutch if the car stalls. We've got a 6-step process for setting that up as well, but again, I won't go too much more into detail. We've got our usual library of worked examples. We'll be adding to that very shortly as well. Again, $149 US if you are interested, and you can find that at hpacademy.com/courses. Right, lastly for today, we've got our latest episode of our HPA Tuned In podcast has been released. This is a really interesting chat with Anthony from Dahtone Racing over in Sydney, Australia. Dahtone Racing specialise in all sorts of GTR cars, actually not just R34s, not quite sure I was going to say that, R32, R33 and R34 GTRs. He's an RB specialist. This is one of those cars that's becoming a bit of an icon, or it's already really become an icon, as we've seen with the soaring prices all around the world. The RB engine, while it has become a bit of a fan favorite, it is not without its set of issues, and we go deep in this episode with Anthony about what the problems with the RB26 are, and more importantly, how to solve them. For any of you who are either running a workshop or contemplating starting a workshop, we also cover in this episode some of the mindset and philosophy that Anthony goes through with how he set up Dahtone Racing and why he has purposely chosen to keep that small and control the quality of the product that he is providing to his customers. All right, we'll finish off just by reminding you there about our Racetech seat giveaway. Remember the Racetech seat, Racetech 6-point harness, and our race driver education course. $2,000 worth of value, 6 days left for that to run. Please don't miss out, get your name into the draw. There is no cost for getting your name into that draw, and great chances that you might end up being a winner. All right, thanks for watching. Give me a moment here. We'll get started with today's lesson. If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.